Okay, let's jump right in. Today, we're doing a deep dive on a very specific piece of gear. It's the DVIGear DVI-7365. So for you, the systems designer listening right now, the mission is, it's always the same, isn't it? How do you move these massive high bandwidth signals over huge distances? And crucially, how do you do it without the signal falling apart? Because copper cabling, it just doesn't cut it anymore.
It just can't handle it, not at this level. You're looking for a flawless image over these really long runs, and that's where this whole optical breakthrough comes in.
Right. So let's start there with quality. I see here this extender supports resolutions up to 4K at 60 hertz with full 4.4.4 color.
And that is the key, that 4.4.4 part. A lot of other extenders, especially over copper or Cat-EX, they achieve the distance by using some pretty heavy compression. This doesn't.
Okay, so hold on. Unpack that for us. We're talking about an 18 Gbps bit rate, completely uncompressed. What does uncompressed 4.4 actually translate to for someone looking at the screen?
It translates to perfection, really. You get zero artifacts. Perfect color fidelity. So if you're in, say, a post-production grading suite, or maybe a high-end simulation.
For a medical setting, I meant?
A medical environment, exactly. Anywhere that color detail is absolutely critical, compression is just not an option. This makes sure the picture that leaves the source is identical to the one you see, even if it's miles away.
Miles away. We'll get to that. But first, the next big challenge is usually consolidation. It's never just a video signal, is it? You're trying to replace a whole bundle of cables.
Yeah, and that's what's so fascinating here, that the sheer amount of stuff they cram onto one single strand of fiber optic cable.
Okay, so what are we talking about?
Well, you've got your uncompressed HDMI video, obviously. You also have multi-channel LPCM audio, so, high-quality uncompressed audio. Then you get bidirectional control signals, things like IR and RS-232. And on top of all that, 2 independent 10100 Ethernet ports.
Wait, networking too? So you're getting video, audio, control, and networking, all down one piece of glass.
All of it. Consolidated.
So that's the big question then. How do you send all that data, the super high-speed video and the slower control data, simultaneously without them, interfering with each other?
Now that is the real secret sauce. This device uses a technology called CWDM, that's coarse wavelength division multiplexing.
Sounds complicated.
It sounds it, but the concept is pretty elegant. Think of it like a prism splitting white light into a rainbow. They're essentially doing that, but in reverse. They're sending 6 completely separate data streams down that single fiber by using different distinct colors or wavelengths of light.
Oh, I see. So it's like having different lanes on a highway.
Exactly. 4 of those lanes or wavelengths are dedicated to carrying that huge TMDS video data, and then 2 separate wavelengths handle all the other stuff, your control data, DDC, and that Ethernet traffic.
And that's the engineering that lets you get these just astonishing ranges. Because with copper, you hit a wall at a few hundred feet. But with light...
With light, distance almost stops being an issue. I mean, the range is tremendous. If you're using single-mode fiber, you can push these signals over 1.8 miles.
1.5 miles. Wow.
3,000 meters, yeah. And even with standard OM3 multimode, the kind you find in a lot of commercial buildings, you're still getting over 1,000 feet.
That distance also brings up another key benefit of fiber, right? The immunity factor.
Yeah.
Why else should a designer choose light over wire?
Oh, absolutely. Because optical transmission is completely immune to environmental signal noise. It has a very low RFI and EMI profile.
So, in plain English,
in a place like a broadcast facility or a command center, there's a ton of electronic noise floating around. Copper cables act like antennas and can pick that up. Fiber is just silent. It's totally reliable, no outside interference.
Okay, so last piece of the puzzle. To make sure this thing actually works with any screen or source you plug into it, you need some management flexibility.
Right, you need it to play nice. And it's very versatile. It has 4 different EDID management modes.
Which lets you force the source and the display to communicate properly.
Exactly. You've got pass-through, a couple of learn modes, and a factory default. And crucially, it supports both the old HDCP 1.4 and the new HDCP 2.2 standards. So all your protected content is going to work perfectly.
So at the end of the day, what this means for you, the listener, is that a device like the DVI-7365 basically solves multiple problems at once. It simplifies your install and guarantees that uncompressed 4K quality over distances that were just impossible before.
And if you connect this to the bigger picture, it's pretty wild. The ability to pack 18 gigabits of video plus audio plus full networking onto a single hair-thin path of light using CWDM, that's a real glimpse into the future. It makes you wonder, How much more data could we consolidate and transmit just by adding a few more colors to that single pulse of light? The scale of that efficiency is, well, it's truly mind-boggling to think about.